The fact that so much of the universe is a mystery to us is baffling. We do everything in our power to explore it as thoroughly as we can, but we are yet to discover a fraction of it. Despite all our efforts, we haven't even landed a man on the closest planet to us yet. Hell, we haven't even encountered extraterrestrial life. We can't reach stars ourselves, so the information we have is just observations, and we have telescopes to thank for that. And even that doesn't show us the full picture, because whatever we can observe in the universe through telescopes is limited to the narrow field of view of that telescope we have at hand. At least it was, until a sea crustacean gave us a part of the puzzle that might help us see the full picture. This is Engineer's Muse, and in this episode, we are going to look at how lobsters might help us have a better understanding of the universe. If we are going to get through this video without losing some of you, we need to talk about how light works, so don't dust off your high school science books just yet. Light, to put it simply, is a form of electromagnetic radiation. Much like sound, which is a mechanical wave, light is an electromagnetic wave that comes in different wavelengths and doesn't require a medium to travel. The screen you are currently looking at emits light in a range of wavelengths that we refer to as visible light. The colors that you see on the screen right now, like red, green, and violet, are just light emitted in different wavelengths. The human eye is only able to see light that has a wavelength of between 380 nanometers, which is the color violet, and 750 nanometers, which is the color red. Light waves that are emitted in a longer wavelength than red are called infrared, microwave, and radio, while the light waves that are emitted in a shorter wavelength than violet are called ultraviolet, X-rays, and gamma rays. Obviously, that's not all there is to light as a concept, but that's as simple as we can put it. Speaking of X-rays, isn't that what you get when you break a bone? Well, yes, but it is also a high-energy form of light. Beyond medical practice, X-rays that reach our planet from space help astronomers get a better understanding of supernova black holes and exploding stars. There are two problems, though. The first one is X-rays have a hard time getting past the atmosphere and cannot be observed from the Earth. This issue is solved by launching the telescope into orbit beyond the atmosphere. The second one is these telescopes usually have a narrow field of view, limiting our ability to observe the universe. To get to the bottom of this problem, researchers had to get to the bottom of the ocean. Lobsters' eyesight works differently than ours. Residing in the harsh environment of deep oceans where light is scarce and food is finite, lobsters have developed their senses to adapt to the environment. Take their eyes, for example. Resting on two stalks, lobster eyes rely on reflection to get a better view of their surroundings. They have thousands of square-shaped tunnels that reflect light from different angles and direct it to the retina. This improves the field of view immensely and was what the astronomers needed in their telescopes to get a bigger picture of the universe. On July 27, 2022, China launched a new type of X-ray telescope that mimicked a lobster's eye, called Lobster Eye Imager for Astronomy, or simply LEA. The telescope is covered with 36 mirrored square tunnels that are installed at a curve. X-rays coming from different angles will hit inside these square tubes and create the image astronomers need. The walls of these tubes are so thin that the fact that they reach the orbit without getting damaged during the launch is a miracle. The curve allows the field of view to be wider, helping scientists capture more celestial events at a time. Just as compression, a NAOC scientist said that previous X-ray telescopes only had a field of view as big as the Moon, and this new telescope can cover an area as large as 1,000 moons. X-ray images of celestial bodies can give us so much data and improve our knowledge of cosmology. All that knowledge through the perspective of an ancient sea crustacean.